Hold it. Okay, I'm going to share my screen now. All right, I'm going to open the book. All right. We look at a couple of examples last lecture. We look at the examples with inherently recursive nature last time. So the problem for finding the directory size and the tau of Hanoi problem. And let's look at one more problem today is this is the fractal problem. All right, so now what is the fractal problem? So let's look at this. It's a very popular mathematical problem and has a lot of applications in many fields. So this is there's a lot of fractal problems. I'm going to show you just one. So in general, what's a fractal problem? It is a geometric figure. This is the it's not like straightforward. It's like just circle, triangle, but it's a very complex one. So this figure is like you have the recursive nature there. So you can look at this. This is the fractal. This is the figure. Fractal is geometric figure. It can be divided into parts, and each of which is a reduced size and a copy of the whole thing. So here's the example. You can see this. We have the at the beginning of this chapter, we look at the H-shape problem. So if you recall that, and this is the H-shape. So I'm going to go back again, and so you can see this. It's the H-shape. So this is the H-shape problem. It's a fractal problem. So if you look at the whole thing here, the whole thing, and look, we can divide it into there's 4 parts, this, and this 4 parts. And each part is just like the big thing, but it's a reduced size. All right. And so now let's look at this one here. We're going to use another example here in this section. This is another fractal problem. And this one is Sierpinski triangle. Okay, Sierpinski triangle. It is named after a Polish mathematician, Sierpinski. So he proposed this fractal problem. So what is this problem? You can see this whole thing, right? The whole thing. And it's divided into these 3 small parts. So 1, 2, 3. So each is the same as the whole thing, but it reduced the size. So how do you look at the size? This is the size. I'm going to start with this is 0. So look, this is the order. So this is now is the order. So this is if this is order. So now you have this is the best case. It is just one triangle. Now look at this is order is 1, and now you have this 3 triangles of smaller sizes. And look at the 2. So the 2 is this. Now you can look at this 2 is This is the big thing. And this is the small 3 parts. So 1, 2, 3. So 1, 2, 3. So each is the same as before, same kind of shape, but it's the size is reduced. All right. So look at this is 3. So this is a 4, and this is 5. So our job is to write a program to draw this Sierpinski triangle. All right, how do you write this program? So if you go with 6, okay, now it's so much to draw. And well, this problem is recursive problem. And so it's inherent to recursive. It is recursive. So you look at this, 3 parts, 1, 2, 3. And it's just the smaller size of the big thing. And the big thing is like this. So if you look at each of this, recursion. So this is the nature of the problem. So the key is here is to identify the pattern, and you'll be able to describe this using a recursive method. So how are you going to draw this using recursive method? All right, so you can see this, this program here. What you see here is from the Rebel book. It's HTML writing and the code using JavaScript. We're going to write the code using Java. So the code is going to be very similar, just a different syntax. Now, I'm going to write this code here. So you know you're going to write the Java GUI program. So when you write Java GUI program, you just set up the user interface and initialize the GUI. All right, and then you are ready to write the key part of this program. So this is I'm going to show you. Let's do this here. All right, I'm going to show you my share another screen with you. So I'm going to share another screen with you. I'm going to stop this share and now reshare a screen. So I'm going to reshare the screen here. Is this? All right, here's the, do you see my entire screen now? You see this command prompt?
Yes, it's visible.
Okay. All right, so here's the code here. Sierpinski triangle, Java, Sierpinski triangle. So this is Java program. All right, so now you're gonna see this is my Java program here. All right, so here is actually 0. So this is 0 here. And so this is 1 and 2 and 3, 4, 5, and 6. You can see this is the pattern. So I'm going to resize it. You can see it a little bit. Now resize this. Okay. All right. So this is. I'll write this code. Now for JavaScript code, so we're going to set up the user interface on this, and now the key part is this drawing. So we're going to draw this shape, and we'll draw this. We're going to use recursion. So what we're going to do is identify. So what you need is this. You need this 3 points to begin with. There's 3 points for triangle. So the top and left, right. So this is the 3 points. Okay. All right. So with this 3 points here, and what about how are you going to draw this? This is a triangle. The whole triangle is 3 points here. There's the big triangle. So this is the big one here. It consists of this 1, 2, this three smaller one. So you're gonna reduce the problem into this three smaller ones. So for this three smaller ones, you need to identify the midpoint right here for this midpoint and midpoint here and midpoint here on this line here. So there's three midpoints. Okay. All right. So now, and for this triangle here, it's right here, from here to top and left to right. And for this triangle here, top, left to right. And for the last triangle here, is top is right here and left is here, right here. So you're going to draw this recursively and draw this recursively. And then it's just going to let the recursion takes away of your code. And so what we need is we need to find out and all these points. And the best case is the order is 0. Once this order is 0, you just draw the triangle. Link these 3 points together. All right, so now we're going to look at this here. The thing the essential code we need is to draw this triangle here. We need to draw, I'm going to call this a display triangle. So this is display triangle. So display triangle, we need to have this 3 points, P1, P2, P3. So these are the data type. This is the point. It's a point. This point 2D is in the Java API. It's essentially just the 1 point. You have this 2 coordinates, X, Y coordinate. That's all. It's here. There's a couple of methods also. Computed distance and computed midpoint. It's in this point 2D. All right, so we need to know the order. That's important. So when you call it again, the next time, hey, what is the order? So that's the order is important. So the order. So here's the order here, right here, the order, the order, the order, right here, the order. All right, so here, if the best case, order is 0. Okay, so that is, you're gonna just draw these 3 points, P1, P2, P3, link them together and to form a triangle. So here's I'm going to create this polygon, and this is the triangle, and add all the points. So this is the P1 dot get X, P1 dot get Y. So this X, Y coordinates for P1 and P2 and P3. And this is the triangle here. It's a polygon. And then I just do JavaFX and get this stroke and fill in the color, and then put it into this triangle into the pen. So this is the best case. All right, so now else, I'm going to do a reduction. It's where you get this points. All right, so this points here, 1, 2, P1, 2. What's P1, 2? It's a midpoint between P1 and P2. So if you look at this diagram, and this is P1, 2 right here. And this is P2, 3. This is P3, 1. So this 3, look at this 3, okay? So I'm getting this 3 now, right here, this 3 points, midpoints. And then we're going to do a recursion. This is display. You're going to draw 3 times, 3, 1, 2, 3. So this is 3 smaller triangles. So their order is reduced. It's 1 is less than the big one. So order minus 1, and P1, P2, 1, P3, 1. So look at what is this. This one is right here. P1, P1, 2, P3, 1. So this is the one. So that's what you're going to do. Look at this display triangle, order minus 1, P1, P1, 2, P3, 1. So now look the rest the same way. So here, and now the next one here is going to have, you're going to recursively invoke this triangle, display triangle, order minus 1. So here is P1, 2. So this, what it will be, this is P2, and this will be P2, 3. So if you go down, look at this part right here, and that's here. All right. So this is the key part of this code. It is this. Now, it's when you write code in any programming language, if you write graphic user interface, it's really simple. You just get the whole picture, the architecture, and the API for the language. And you need to study it incrementally, just get examples, simple one, and then add more features and see how the control works and button, checkbox, radio buttons, and then just go with list combo box and see all those things, how they work in the API. And so with all this, they're very similar. So whether you're using Python, using JavaScript, and using this Java, so they're really very, very similar. All this, the way how you write the event-driven programming, and with all this, and the key part is this: the how like this, how you write the recursive method. All right, so that is the one here, the Sierpinski triangle. And so this is the inherently recursive problem. It is difficult to write the code without using recursion.
So we can't put a negative integer in the order text box, or does it account for that?
No, that's not gonna work. Yeah.
Okay, I figured.
You feel some error. Okay, let me go back to reshare my screen. I'm gonna stop this, and so you can get a better look now of this. All right. Okay, now what we have done now so far. So we know what is recursion and how to write recursive method. And so now we're going to get to the next one is this. Recursion versus iteration. When to use recursion? Recursion is a very useful, very powerful tool. And so you just add more now in your toolbox to solve your problem. So when you're going to use this recursive approach, and you're going to use it for the problems that has inherent recursive nature. So that will enable you to develop the code straightforward and simple, and also most likely it's efficient. It is efficient because you're going to see because of nature of recursion. And so that's my advice. That's the general rule. It's when you're going to use recursion. It's for recursive structure, for recursive nature of the problem. If the problem it doesn't really have inherent recursive nature, and just use iteration, it is more efficient. Because when you use recursion, you're going to see you have a lot of calls in the program behind the scene, and that will increase your memory use and also your it's time consuming for this managing the call stack. So in general, if this solution, it's really simple, just writing loops and using the loops is more efficient. Okay. All right.
So I have a question.
Yeah.
So there's never a case where, like, I mean, I know memory usage is another issue, but I mean like performance, like CPU time. So it's almost never the case, if ever, that like it's faster to invoke the method multiple times versus just iterating, right?
That's right.
Okay.
That is true. Absolutely. All right. So I'm going to touch on another issue is this. It's tail recursion. So go down to the next one here. If you can write a code with the tail recursion, and that is guaranteed to be efficient, So what is tail recursion? Tail recursion is this kind of problem. It's you write this method like this, A. So the last one you're going to invoke, it's this. You invoke this A recursively. And then after this, there's nothing to be done. So like this here, this is tail recursion, but this is non-tail recursion here. And after you invoke this B recursively, but you still have to come back to fix something, to do some work. So this is a non-tail recursion. This is tail recursion. So we have a bunch of examples in the book that tail recursion. Like this is a palindrome. So that is the tail recursion. So because once you return it, it is over. There's nothing needs to be done. So you can go back to look at it. I'm going to give you an example here is this. It's factorial. So I'm going to open another window if I can. I'm going to open another window here. Just a second. I'm going to open another window. I'm going to show you here. So I'm going to open another window here. Another tab here, okay? Just another tab. All right, I'm gonna scroll down to this. All right, computing factorial. Okay, this is not tail recursive. This factorial here. So we're gonna compute this factorial right here, and then recursively call this factorial n-1, but it's not over. Look, it's not over. You have to go back to do this n times factorial n-1. So this is not tail recursive. All right, give you an example of tail recursive here. Let me open another tab. So going to this palindrome. So remember this palindrome here. It's and let's go with this one here. Upper method. All right, so let's look at this here. It's palindrome right here. So this is tail recursive because now look here, recursive call. It's going to return true or false. And after this is returned back, you don't have additional work to do. That's it. So that's tail at the very end. So this is called tail recursive. All right, so you're going to see that this is not, factorial is not. But I'm going to rewrite this code, rewrite it. So just rewrite this code. So this is how I'm going to rewrite it. It's this. Rewrite this code. It's not intuitive, but you're going to see this is the one here. So look here. This is you're going to call factorial n right here. So you get the number, prompt the user to enter a non-negative integer. So right here. And now you're going to call this is factorial, this one here. Okay. So this is, I'm going to use this factorial n1. So what is n1? This is n result. So here, if this n is 0, I'm going to return the result. Else, I'm going to return factorial n-1, n times result. So here, you're going to return the whole thing. This is the return. This is the recursive method. So this is recursive method, recursive call. So once you return, there's no additional work afterwards. This is tail recursion. So to see how it works, you can look at this animation after this class. Just go and see why it's efficient, because the compiler optimizes it in C++, and in most languages I know they can do this tail recursion optimization. So you write the tail recursion, it's going to be guaranteed it's efficient because the internal compiler optimization. The reason is you don't have to put things on the core stack, because there's nothing you need to store it after return. It's all gone. It's good. Go back to the original code. All right. So this is the tail recursion. So let's see. Let me go back to this one here. I'm gonna go back to this. I'm gonna go back to look at one more exercise here. So look at this one exercise here. Just do one more together. Okay. Okay. I'm gonna write this code with you and see if you can catch errors here. So here's the description here. The nth harmonic number is defined non-recursively as n1 plus 1/2 and plus 1/3 and plus 1/4, and the last one is 1/n. So come up with a recursive definition and use it to guide you to write a double returned method named harmonic that accepts an int parameter n and recursively calculates the return of n's harmonic number. So we're going to do it recursively. And so here we're going to first write this method. It's public static. So we're going to return is double, and the name is called harmonic. And this is the parameter. It's accepted as. All right, so we got this now. So what is this? This is going to return here, but all this expression here. So this is one here. All right. So what we need to do is look at reduction here. Is if n is 1. Okay, so that's the best case if n is 1. So you're going to return 1. Okay, so this is okay. It's double. You can say 1.0 or just 1. It should be fine, because it's if it's int, it goes to double. It's automatic conversion. So there's no need to cast it. So this is okay. So here, else return. So what we're going to do, we're going to get this last one here. So we're going to have this is the harmonic here. Harmonic n minus 1. So everything from this 1 to before this last item. So it is here, n minus 1 plus. So it's all right. So now if you run this code, it's not going to be correct. The reason is here. It's 1 divided by n. It's integer division. You're going to get 0. So you need to put 1.0. So with this, and you give it a try. All right, so it's correct now. All right, let's go down to the end. Let's do one from the program project. So we're going to go down to the last one here. It's the program project right here. So let's do this program project. I'm going to go a little bit here over. What about the last one? Let's see if I do the last one here, 5. All right, so here, decimal to binary. Okay. If you have questions, don't send me the chat because I cannot read this chat. Okay, so yeah, just speak to me directly. So here, write a recursive method that converts a decimal number into a binary number as a string. So here is the method binary, the decimal to binary. So decimal to binary, and this is the recursive method. So we take this integer here, it's a decimal number. So like here, 35, you're going to return a binary as a string. So this is, okay. So here's another example here. So this is the value here. This is decimal. Okay. So write a test program that prompts the user to enter a decimal number and displays its binary equivalent. All right, so we're gonna go to, so when you write a code, please don't just use this as your IDE. Okay, don't use this as IDE. So what you use is, you're gonna use this after you already developed the code, you copy and paste it into this. Okay, so I'm gonna show you, I'm gonna do this, and from here is writing the code. So let's do this. I'm going to share my screen now to you. Reshare my screen here. So this, I'm going to copy and paste here. Yeah. Okay, what ID do you use?
VS Code.
Okay. It doesn't matter which one you use. Okay, use the one you like. Okay.
Yep.
So, all right. I'm going to just write a code to see here. Directly put the code right here. So just to save some time. Okay, look, it's public class. This is the class name here. Okay. All right. Okay. So here you're gonna have a main public. I'm gonna just copy the main here. Okay, so quickly here. So I'm gonna see if I can just copy my code here. All right, I'm gonna copy it here, so same time. Okay. All right, so I'm just copy the code here. So this is the code here. It's the demand. So we're gonna prompt the user for this input. Just write it exactly as this. Enter a decimal integer. So here, and this is the you get this integer and read it. So this is using the scanner here for the standard input, and this is going to be so decimal. Okay, is so this is okay. So decimal. Okay. So here is this. Okay, so to match this this output here, decimal is binary. Okay, here is binary. So we're going to invoke this method, deck to bin decimal here. Okay, this is one here. All right, so now I'm going to write this, and this is the head. Copy this head right here. Okay, so how are we going to do this? So how do you convert a binary, a decimal to binary? You're going to divide this decimal by 2 successively, and thus the remainder is the 1. So that's just this is very common, so you need to know all these number systems we have for the computer system. You can look at this. I'm going to go back here. So you can look at the appendix in the book. So look at the appendix for this, all the number systems. Okay, so do you see this at the very end? At the very end, do you see this appendix F? It's right here. So appendix F, you can see this, all this numbers, popular number systems. So here's conversion between binary and decimal numbers right here. Okay. So take a look of this. And this, if you're not familiar with this number system, so this is and how, and we convert from binary to decimal and from decimal to binary. All right, so okay, I'm gonna go back here. So this one right here. All right, I'm gonna put this right here. So writing this using recursion. So what's the best case if value is 0? So what you're gonna return?
0.
Yeah, 0 as a string. So 0 as a
Yes.
string. Okay. And else. Okay. So
shouldn't it be equal 0? So this value equals 0.
yeah. Thank you.
What if it's 1?
Value is 1. You can return value 1, but let's see if we can reduce this here in this. We're gonna do now. We're gonna return. So
If the value modulus 2 is equal to 1, would we add 1 to the string, like an empty
Yeah,
string,
I
and
think
then
there's
start from there?
going to I think there's going to be a small problem. I'm going to try to do this now, see what happens. So you're going to say, next, I'm going to say this, return this to being. And here it's value divided by 2 and plus, and this is value remainder 2. So if you're doing this, okay. All right, it's not going to be right. Yeah, there's something here. We probably have to introduce another helper method for this. So let's go to copy and paste here. The one, so we're going to use, anyway, if you have issues, logical error, you're going to use this check exercise tool. So I'm going to go back to, this is the tab here. Let's go to this HTTPS frequent asked questions. All right, so this is the website here, and I'm gonna go to right here. So there is a hint here, okay, for this one here. So here is which one? It's 18 point, what is the number? 18.21, right? So this is the one here. All right. So I'm going to open this up and copy and paste the code right here. All right, so here, decimal number 7, okay? So the binary is 111. All right, so now if you compile and run, so this is what you get. You're gonna see this. Oh, I got error here, scanner, okay. So I'm gonna import java.util.scanner. Okay, and now and run the code. All right, see the problem here I got is 0 right here. So this, I think what we need, we can, how do you fix this? There's a couple of ways to do it. We could just so this is the, because of this. So if you have the number, let's say if you have this is the input is 0, that's fine. So if this is 0, and you're going to return 0. But if this is 1, okay, so you are going to return. Okay. Let's see if this is going to work better. So else, maybe that will fix that error here. If it's 1, I think still we're gonna maybe have issue. So let's try this. So if this is going to be better solution, I'm gonna have a 7 now. Okay, I'm gonna have 8. Yeah.
Is it because in the non-base case, so the tail, we're doing integer division? I don't know, like if that has it like divided by 2 like that.
Divide by
Is that
2. So
intentional?
Yeah, no, you have to do this divided by 2. So this is how it works. So if you go back to look at this appendix for this converting decimal, so you do a division you do successively divide this value by 2.
Right.
So the remainder is the one. The remainder is the one you keep it here. So
Okay.
if you
I'm
go
just thinking like for the number, like say you do like I don't know, like 7 as the initial value, and it goes you know, obviously 7 isn't 0, 7 isn't 1, 7 divided by 2, would it just be 0? Would it just truncate the value there?
Oh,
What would be the,
7 divided by 2 is 3. It's integer division.
okay, so it just truncates it.
Yeah, it truncates. Yeah. Okay.
Okay.
All right. I think this is actually worked. That's right. So you can now copy and paste and back to this and submit it. Okay. All right. Now submit. Okay. Super. All right. All right. So it's there's a really many different ways to do it. I think this is probably the easiest, yeah, the most clean, yeah, code. All right. So you can see this is a really simple solution, and for this using recursion. Yeah. Any other questions? So if you have any questions, you can stay here, and otherwise, please feel to leave. And thank you very much.